children, before I begin with the 2A questions of probability, let me discuss with some of the tricks by which you can write down the sample space when you are tossing a coin, tossing 2 coins at a time, tossing 3 coins at a time. So instead of thinking and writing, we can directly use a formula and write. See children, when we toss 1 coin, what is the outcome? If you are tossing a coin, what can be the outcome? Yes, there can be 2 outcomes, either there can be head or there can be tail. So outcome in coin is 2. There can be head or there can be tail. And when we are tossing a dice, what can be the outcome of tossing one single die? In a die, there are 6 faces, children, that you will be seeing in the question when I am explaining the sums. I have shown the 6 faces. Everyone must have played Ludo game, and you know there are 6 faces in a dice. So outcome in a dice are 6. I can show you once again. I hope you can see one face which has 1 dot, another face which has 2 dot, 3 dot, 4 dots, 5 dots and 6 dot. So there is the outcome. How many outcomes can be there? 6 outcome. Okay, that is 1, 2, 3, 4, 5 and 6. In coin there are outcome 2 only, head and tail, and in dice there are 6 outcome. Clear? Fine. So when one die is thrown one time, you can write 2, 1. So what will be the sample space? 2. The sample space will be 2. Okay. If 2 coins are tossed, the formula for writing the number of sample space is 2 raised to n. 2 raised to n. What is n? N is equal to number of coin. Number of coins. And what is 2? Outcome. If you toss one single coin, there can be 2 outcome. But every time in every coin the outcome will be 2 only. But if you toss the coins, 2 coins at a time, what will be the number of sample space? But the possibility in one coin is only head tail. The outcome can either be head or tail. So outcomes are only 2, but number of coins can change. So n is the number of coin and 2 is the outcome. So when we are tossing one coin, sample space will be 2. When we are tossing 2 coin, here n is what? 2. 2 raised to 4 means 4. Sample space is 4. Is 4. So how to write that? Okay, now if you are tossing 3 coin, sample space will be 8. If you are tossing 4 coins, sample space will be 16. Now how to write that? Let us see. 2 raised to 1 means 2 sample space, and it will be head or tail. 2 raised to 4 means 4 sample space. So how to write that 4 sample space? Head, tail, head, tail. One time head, one time tail, one time head, one time tail. Now 1 2s are 2. So 2 time head, 2 time tail. So this will be your sample space, children. Okay. So you can write down in a roster form: head head, head tail, tail head or tail tail. Okay, when 2 coins are tossed. Now when 3 coins are tossed, 2 raised to 3, 8 sample space. So how to write that 8 sample space? Means you will write down 8 one time, head, tail, head, tail, head, tail. 1, 2, 3, 4, 5, 6, 7, 8. 8 sample space. Now 1 2s are 2, so 2 head, 2 tail, 2 head, 2 tail. Now it is what, 3 coins na? So 1 2 3. So yeah, 2 2s are 4, 4 head and 4 tail. So this 1 2 3 4 5 6 7 8 when 3 coins are tossed. Okay. Now in the sum when I am solving, I have also shown here I have began with head. You can also begin with tail if you want. Suppose, and now you can write down the sample space of it. See, H H H, then H H T, then H T H, H T H, H T T, T H H, T H H, then T H T, T H T, T T H, T T H, then T T T. Okay. This is when 3 coins are tossed. Suppose if 4 coins are tossed, what to do? Now if 4 coins are tossed 16 sample space by the formula. So how will I write? 16, let me rub this, children. So H, one time, first one time head, one time tail, for how many times? 16. Okay. So H T H T H T H T H T H T H T. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Okay. See, began with H, H T H T H T H T H T, 16 sample space. Okay, because you want 16, 4 coins are tossed. Now it is one time you want here. 1 2s are 2. Now 2 time head, 2 time tail, 2 time head, 2 time tail, 2 time head, tail, head, tail, head, tail. Okay. But here 4 coins are there, na? So here we can see only 2 coins. Let us see. Now 2 4s are 8. 2 2s are 4, sorry, 2 2s are 4. So 4 time head, 4 time tail, 3 4. 1 2 3 4. 1 2 3 4. Now 4 2s are 8. 8 time head, 4 5 6 7 8. 8 time tail, 1 2 3 4 5 6 7. 1 2 3 4 5 6 7 8. Here 1 2 3 4 5 6 7 8. So this is the sample space for the 4 coins to be tossed at a time. Then you can write it in roster form like this. I have began here with head, you can also begin with tail. So if I am beginning with tail, so tail head, tail head, tail head, then you have to begin 2 time tail, 2 time head, 2 time tail, 2 time head. Like that you can write sample space in case of coin. Now let us begin with case of dice. In a dice, outcome are 6. So when one die will be thrown, if you are using formula 6 raised to n, this is the outcome and this is the number of die. This number is outcome. And what about this? This is number of dies. Okay. If one die is there, n can be equal to 1, 2, 3. Okay. If one die is thrown, the outcome will be 6 raised to 1 is 6. See, if I am writing one die is thrown. 1, 2, 3, 4, 5, 6. Got 6 is there. Okay, sample space. Sample space. This is sample space which I got 6. Number of sample space I got 6. In case if 2 dies are thrown, outcome and 2 dies, then what will be the sample space? 6 raised to 2 means 36. So this was easy to write. 1, 2, 3, 4, 5, 6. How to write 36? That becomes difficult. That there is a way of writing. One trick is there, children. 36 are there. So let me write 1, 2, 3, 4. Let me write it here. 1, 2, 3, 4, 5 and 6. And checkerboard like. Okay, we can make checkerboard type. And from here 1, 2, 3, 4, 5 and 6. Now you can easily write. See, 1, 1, 2, 1, 3, 1, 4, 1, see 4, 1, 5, 1, 6, 1. Then comes 1, 2, then 2, 1, 2, 2, 3, 2, then 4, 2, then 5, 2, then 6, 2. Then comes 1, 3, then 1, 4, 1, 5, 1, 6. Then 2, 3, 2, 4, see, 2, 4, 2, 5, and then 2, 6. Then 3, 2, 3, 3, sorry, 3, 4, then 3, 5. Are you seeing what I am doing? This. Now 3 here and 6. Like this, x-axis and y-axis. Okay. Now then see, 4 and this is 3. 4, 3, then 4, 4, then 4, 5, then 4, 6, then 5, 3, 5, 4, I am keeping my finger, see, 5, 5, then 5, 6, then 6, 3, 6, 4, 6, 5 and 6, 6. You won't make any mistake. And this is the number of sample space, element of sample space. Then you write it in roster form. Sample space will be, then you see 1, 1, 1, 2 and 1, 3, 1, 4 and 1, 5 and then 1, 6. Okay. Then and so on. Like that also you can write, but if you want to not make any mistake, you must write like that. Then if you want to write 3 dice are thrown, 6 raised to 3 means 6 into 6 into 6, 36 into 6, 36 into 6, 216. So if 3 dice are thrown, number of sample space will be 216. This is not there in your syllabus. They don't usually ask you if 3 dice are thrown, write the number of sample space or write the element of the sample space. If you are asked to write number of sample space, if 3 dice are thrown, then you use this formula 6 raised to 3, 6 into 6 into 6, 216, and number of sample space you get, and then probability you can write. But usually it is not asked. So now we will continue with 2A and 2B. I hope children you would have understood. If you don't understand, rewind and see. Children, now we will begin with 2A of the chapter probability. Question number 2A. Out of 3 activity, any 2 activity you will have to attempt, and each activity is of 2 marks. So the first activity is if one die is rolled. Children, you know a die. I'll show you a die now. Children, can you see the die? This is one face of the die where there is one dot. Then you can see another face, there are 2 dots. So therefore here it is written 2 dots. Then you can see the third face where there are 3 dots. Then you can see fourth face, there are 4 dots. Then you can see fifth face where there are 5 dots, and this is the face where there are 6 dots. So the sample space is 1, 2, 3, 4, 5, 6. Means on the face there was 1 dot, 2 dot, 3 dots, 4 dots, 5 dots and 6 dots. So therefore number of sample space, how many are there? 6. Means total element, how many are there? 6 are there. So we have to find out event in which the number should be a prime number. Children, you know what is a prime number? A prime number, out of this we have to select which one is the prime number. So prime number is a number which can be divided by 1 and by itself. Let us see for the first number. First number is 1. 1, remember, is not a prime, not a composite. So we don't have to include 1. 2. 2 is a prime number because 2 can be divided by 1 and 2 can be divided by 2. 3 is a prime number because 3 can be divided by 1 and 3 can be divided by 3. But no other number can divide 3 except 3 and 1. 4 is not a prime number because 4 can be divided by 1, can be divided by 2, can be divided by 4. Then we go for 5. 5 is a prime number because 5 can be divided by 1 and also 5 can be divided by 5. But there is no other number which can divide 5. So there are total 1, 2, 3 numbers which are a prime number out of this sample space which is given. So number of element in A is already given 3 and we also got 3 element. So what is probability? Probability is number of element in A. This is the formula, children. Number of element in A upon number of element in S. What is number of element in A? 3. Number of element in sample space 6, which is already there. So 3 ones are 3 twos are. So what we got? 1 upon 2. So answer for this activity is 1 upon 2. This is how you will be able to solve this activity. Second activity, 2 coins are tossed. When you toss 2 coins, write the sample space and expected sample space in the event which are by completing the activity. So what is the event? First event is to get at least 1 head and event B is to get no head. So when you toss 2 coins, if you toss 2 coins at a time, children, there can be head. Okay. This is first coin, this is second coin. So again the coin is there. So there can be tail, head. Okay. First and second coin. Then there can be both tail. Yes. In both the coin there can be tail. First coin, second coin. See now, first coin was head, then the first coin was tail, and second coin was head and head. then tail and then tail. Now one more possibility can be there. Head, head, tail, head, tail, tail. Now head, tail. There can be, okay, head, head, tail, head, tail, tail. Here tail, head is there, so head, tail can be there. First coin can have head, second coin can be tail. Yes, so head, head, tail, head, then head, tail we have already written, it is already there. Then what is left? Tail, tail. Now to get at least one head, at least means least to least is one head, but there can be more than one. That is known as at least. For example, if somebody asks to distribute something, and while distributing he or she may say everyone must get at least one. At least one means at least to least is one, but not less than one. But one can get more than one. One can get more than two, but not less than one. That is known as at least one. Okay. So here head, head, to get at least one head. One head, where is one head here? This is one head. This is one head. But there can be two head, but there cannot be zero head. So head, head, tail, head, there can be head, tail. Did you understand the meaning of at least one head? Means there can be least to least one, but not less than one. There cannot be zero, but there can be more than one. There can be two, there can be three, there can be four, but there cannot be zero. That is known as at least. Next event is which one? To get no head. Now where is no head? Here there is two head. There are two head. There is one head. There is one head, but there is no head. So tail, tail can be the event of getting no head. Children, you can, I hope you must have understood it. You can pause and you can solve the sum. Activity number 3. There is a card which is drawn from a well shuffled pack of card, and the pack of card is containing 52 cards. So the event A, card drawn is a red card. So we need to write down the event A where the card drawn is a red card. Children, in a card, pack of card, you must have seen, everyone, there are 13 cards, black cards, 26 black cards are there. This symbol you must have seen. This is 13 cards are there of this, which is black in color. Then there is diamond, which is red in color. Then there is heart, which is red in color. And these are 13 cards. Black, 13 cards are there. Spade, this is club. Club, 13 but black. Red, diamond, 13. Heart, red, 13. So 39 cards. But there are how many? 52. So one more is left. Spade, and that is like this. So again it is black. Spade. Most of you must be playing cards, and that time you would be getting to see that there are 13 black card which are spade, 13 club which are black, diamond 13, heart 13. So here the question is, total red cards how many are there? See, there are only 2 red, diamond 13 red cards, and which is already given for you, and 13 hearts. When you add 13, 13, 13, 13, total 52 cards. So number of element in A is how much? 13 plus 13, 26. Here already it is given 26 upon 52. So 26 ones are 26 twos are. So you got 1 upon 2. So probability of A of getting red card is 1 upon 2. Means there is 50% probability of getting red card. 13 heart, 13 diamond, total 26, and black 26. So 26 are red and 26 are black. So probability of getting a red card is 1 upon 2. 1 upon 2, therefore I said 50%. 1 upon 2 means half. 100% all. So 1 upon 2 means 50%. Question number 4, children. In Adarsh High School, out of 30 students, 3 students wears glass. Means there are 30 students in a class and out of them 3 students are wearing glass. Glass means spectacles, specs. If a student in class is randomly selected, if you select the student randomly, then find the probability that he or she wears a glass, he or she wears a spectacles. So you have to find the probability. So the activity is there. Let us see, there are total 30 students in class. So number of sample space will be 30. Event A, selected student wears a glass. How many students are wearing glass? Only 3. So let's write number of element in A is 3. Probability of A means number of element in A upon number of sample space. So how many number of element, what will come here? It will come number of element in A upon number of element in sample space. Now apply the formula. If I want to solve it, what will I get? Number of element in A is how many? 3. 3 upon number of element in sample space 30. So 3 tens are, so it will be 1 upon 10. So probability of A is 1 upon 10. Children, you can pause and you can solve this. For so easy question. Question number 2B, we have to solve the following, children. Out of 5 questions, any 4 will have to be attempted. You have to attempt only 4 questions and each one is of 2 marks. And from the chapter probability. See the first question of 2B, a card is drawn at random from a pack of well shuffled 52 cards. Children, you know pack of card contains 52 cards, and before this only I discussed which type of cards are there. So find the probability that the card drawn is a spade. This is the symbol of the spade, children. Sorry, club it is. The spade is like this. Okay. So how many cards are there which are of spade? There are 13 cards. There are 13 spade cards. Now, we have to find the probability. A card is drawn at random from a pack of well shuffled 52 cards. So number of sample space will be 52, children. Total number of cards are how many? 52. So NS is equal to 52. Let A be the event that the card is a spade. So A is equal to, number of element in A will be equal to how many? It will be 13, because there are 13 spade. Let me draw again. 13 spade and there are 13 club. Then there are 13 diamond, then there are 13 hearts, and all together it makes 52 cards. This is red in color, this is red in color, this will be black, and this also will be black. So 13 spade cards are there, 13 clubs are there, 13 red diamonds are there, and 13 red hearts are there. Altogether they are 52 cards. So from a pack of 52 cards, you will have to remove randomly a card which is of spade. So let A be the event that the card drawn is a spade. So number of element in A will be 13. We want to find out the probability. Now earlier while solving A questions, we have learned the formula of probability, and that formula is probability of A is equal to number of element in A upon number of element in sample space. So what are the number of element in A? They are 13, and number of element in sample space are 52. 13 ones are 13 fours are is 52. So we get probability of A, or the event of getting probability of getting a card which is spade is 1 upon 4. You can pause the video and you can solve the sum, children. Question number 2. 2 coins are tossed. Find the probability of event getting head on both the coins. When you toss 2 coins, the number of sample space, the element in sample space will be head head, then head tail, tail head, or tail tail. So number of sample space would be 1, 2, 3, 4. Let A be the event of getting head on both the side, head on both coins. So A is equal to only one number of element in A will be only 1. We can say like that. First write down the element. A is equal to H. So number of element in A will be equal to 1. Probability of A is number of element in A upon number of element in sample space. This is the formula. So number of element in A is 1 and number of element in sample space is 4. So the probability of A is equal to 1 upon 4. Question number 3. If one die is rolled, then the probability of event that the number on the upper face is greater than 6. Children, I have shown you in earlier question of 2A what are the up faces. So if a die is rolled, then what will be the number of sample spaces? Let me write the sample space. That would be 1, 2, 3, 4, 5 and 6. You have seen the faces, there are dots. There is on one face 1 dot, 2 dots, 3 dots, 4, 5 and 6 like that. So sample space would be this. So what is number of sample space? 6. Find the probability of the event that the number on the upper face is greater than 6. Let A is the event that number is greater than 6. Okay. So if I write A, which is the number which is greater than 6 here? No number, it is empty. So what will be number of element in A? It will be 0. Therefore, what is probability of A? We have to find probability, na children? Probability of A is number of element in A upon number of element in sample space. What is A? A is 0. So 0 number of element in sample space is 6. So 0 upon 6 is equal to 0. So probability of A will be 0, children. You can pause and you can solve the sum. Question number 4. If 3 coins are tossed simultaneously, find the probability of the event to get no head. Now children, I have shown you 1 coin is tossed, 2 coins are tossed. Now we are going to see for 3 coins. Now let me show you a shortcut trick how to write. If suppose for example we have 1 coin to be tossed. Children, here I will be giving you a shortcut formula. For any number of coin to be tossed, what will be the number of sample space? The formula for writing the sample space is 2 raised to n. Remember this. This is the formula for sample space. Now what is this 2 raised to n? N is the number of coin. Okay, suppose if 1 coin is tossed, 1 coin is tossed. So what will be the number of sample space? 2 raised to 1, that is equal to 2. If you toss a coin, there can be head or there can be tail. So sample space are 2. Okay. If 2 coins are tossed, so 2 raised to 2, that would be what? 4. So number of sample space which you will get will be 4. Sample space will be 4. Now how to write that 4 sample space in a shortcut way? See, first you write head, tail, head, tail. 1, 2, 3, 4 sample space. Now after writing head, tail, you write 2 time head, 2 time tail. Now after writing 1 time head, tail, why should you write 2 time? Because 1 2s are. Okay, so this will be the number of sample space for the 2 coin to be tossed. 2 coins. Number of sample space is HH, HT, TH or TT. Clear? For 2 coins. Suppose I want to find out for 3 coins. If 3 coins, here the question is of 3 coins. So 2 raised to 3 will be there. 2 raised to 3 means 8. So number of sample space are 8. For number of sample space 8, 3 coins. What? How to write that? See. Head, tail, 1, 2, 3, 4, 5, 6. Let me write from here. Head, tail, 1, 2, 3, 4, 5, 6, 7, 8. Head, tail, I wrote 8 times. 1 time. 1 time head, 1 time tail. 1 time head, 1 time tail. Now 1 2s are 2. So 2 time head, 2 time tails, 2 time head, 2 time tail. 3 coins are there, na? So this is 2. Now after 2 head and 2 tail, 2 2s are 4. 4 time head, 4 time tail. So what are the sample spaces? HH. So these are the sample spaces. So it becomes easy for you to write down the number of sample spaces. You don't have to think about so much where to write head, where to write tail. This is one of the shortcut method of writing the head or tail when any number of coins are tossed. So now then you can write sample space. Let me rub. So for 3 coins, sample space would be HH, HHT, HTH, HTT, THH, THT, then TTH, and TTT. So how many sample space? 8. Let us count 1, 2, 3, 4, 5, 6, 7, 8. Remember formula, children? If any number of coins are asked to write down the sample space, you use the formula 2 raised to n. N means how many coin? If one coin is there, 2 sample space. So you write 1 time head, 1 time tail. If 2 coins are tossed, 2 square means 4, 4 sample space. So you write down 1 time head, 1 time tail, 1 time head, 1 time tail, 1, 2, 3, 4. Now 1 2s are 2, 2 time head, 2 time tail. So 1, 2, 3, 4 sample space when 2 coins are tossed. 3 coins are tossed, 8 sample space. 8 sample space, you write down, it is not needed that you start beginning from head only, you can also begin from tail. If I want to begin it from tail, let me write it. For example, my 3 coins are tossed and I want to write down the sample space, and I got sample space as 8. So if I want to write beginning with tail, so write 1 time tail, 1 time head, tail, head, tail, head. 1, 2, 3, 4, 5, 6, 7, 8. Written. Now what you want to, 1 2s are 2. Now you begin with 2 time tail, 2 time head, 2 time tail, 2 time head. Okay. Now 2 time tail and 2 time head is 2 2s are 4. 4 time tail and 4 time head. See now. TTT, TTH, THT, THH, HTT, HTH, HHT and HH. Either you begin from tail or you begin from head. You can write down the sample space. So this is the sample space for the coin number 3. If there are 4 coins, what will be the sample space? Let me rub it. First of all, if 4 coins are tossed, 2 raised to 4 means 2 2s are 4, 2s are 8, 2s are 16 means 2 4 time 4. 2 2s are 4, 2s are 8, 2s are 16. So what sample space would be there? 16. So I need to write down 16 sample space. So let me write H T. Let us begin with H. H T H T H T H T. 1 2 3 4 5 6 7 8. Further here let me write 16 sample space are there, na? So let me write here 1 2 3 4 5 6 HT 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 1 2 3 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. I began with H. Now 1 head 1 tail. So 1 2s are 2. Now what will come? 2 head 2 tail. So 2 head 2 tail. 2 head 2 tail. 2 head 2 tail. 2 head 2 tail. Okay. Now 2 2s are 4. 4 head 4 tail. 4 head and 4 time tail. Now 4 coins are there, na? So here we got 3 only, 4th one. Now 4 time head and 4 time tail is there. So 4 2s are 8. So 8 time head and 8 time tail. So H 2 3 4 5 6 7 8 and 8 time tail. 1 2 3 4 5 6 7 8. So how many sample space? 16 sample space. Without any tension and strain, you could write easily any number of sample space by using the formula 2 raised to n. So if whatever the number of coins are there, that you will have to power. N is equal to that number of coin. If one coin is there, n is equal to 1. 2 coins are there, n is equal to 2. So 2 square is 4 sample space. And then again you have to use the formula. Remember, one time head, one time tail. So according to the sample space you go. Sample space are 4, so you only write 4. 4 time head, tail. 2 coins are there, so you only write this. 3 coins are there, then you write. According to this, you can write any number of coins given to you, sample space. So let's go to the question, children. The question is 3 coins are tossed simultaneously and we have to find the probability of getting the event of no head. When you written the sample space of 3 coins, 1, 2, 3, 4, 5, 6, 7, 8. So number of sample space is equal to 8. A is the event of no head. If A is the event of no head, what will be number of element in A? What will be the element in A? Let us say, what will be the element in A? No head. This is head, this is head, this is head, this is head, head. So there is only one. So tail. A is the event of getting no head. So there is somewhere here 3 head, 2 head, 2 head, 1 head, 2 head, 1 head, 1 head. So it is to get no head. No head means tail. So number of element in A is equal to 1. If number of element in A is 1, what is the probability of A? Probability of A is what? Number of element in A upon number of sample space. And what is number of element in A? 1. And what is number of sample space? 8. So 1 upon 8 is the answer, children. You can pause and remember when you want to write down the sample space by using this formula, you can write easily. Question number 5, last question of 2B from probability chapter. There are 30 cards in a box. So sample space 1, 2. There are 30 cards in a box bearing numbers. Okay, I have not written. Bearing numbers. Now, if the cards are bearing the number, it will be what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, then 21, 2, 23, 24, 25, 26, 27, 28, 29 and then 30. Children, why I wrote? So that you know what number is the card bearing, or you can, if you know it, you can just write like that. 1, 2, 3, dot and then finally 30. Means the cards are bearing the number 1 to 30. You can write like that, okay, in exam. So find the probability. One card is drawn at a random so that the card drawn is a multiple of 5. So that the card drawn is a multiple of 5. Card is drawn at a random. Find the probability. I never wrote here. Find the probability. Okay, children. Sorry for that. Find the probability so that the card drawn is a multiple of 5. We know the sample space of the cards which are there in the box 1 to 30, and what it is multiple of 5. We have to find the probability that the event is multiple of 5. So let A be the event. What will be the sample space? All the numbers which are multiple of 5. What do you mean by multiple of 5? Means if I take 5 and I multiply it by integers, the numbers which I get Those numbers are what? These are integers. Okay. So what will be there? 5, 10, 15, 20. These numbers are known as multiple of 5. If I multiply the number with the integer, the numbers which I get, they are multiples. So what number I am having? 5. So I have multiplied with the integer, I get the numbers, and they are the multiple of 5. So which are those numbers? See, 5, then 10, then 15, then we get 20. If I multiply by 5, I will get 25. If I multiply by 6, I will get 30. So which are the number which will come in A? 5, 10, 15, 20, 25 and 30. So what will be the number of element in A? That would be 1, 2, 3, 4, 5, 6. 6. What will be the probability of A? Probability of A means find the probability that the card drawn is a multiple of 5. Probability of A is the probability that the card drawn is a multiple of 5. P of A is equal to N of A upon N of S. This is the formula, children. If it is P of B, N of B upon N of S. It is P of C, N of C upon N of S. But N of S will be same for everyone, but here this one will change. If P of B is there, it will be N of B. If P of C is there, it will be N of C. If P of D is there, it will be N of D. Other everything will be remaining same. Here probability of A, so it will be A. Okay, probability of A is equal to N of A upon N of S. Clear? So probability N of A upon N of S. N of A is what? 6. 6. N of S is what? N of S, I have not written, let me write N of S. N of S means total number of elements which are there in sample space. What are they? 30. Total number of element are 30. So I will write here 30. 6 ones are, 6 5s are. So probability of A is equal to 1 upon 6. Children, you can pause and you can solve the sum. We are done with the 2 questions of all 4 chapters, 2A as well as 2B. Now we will go with the next video of 3A and 3B, children. Thank you for watching. Please like, comment, share and subscribe, children.